Welcome to our lesson on solving systems of equations using matrices. In this lesson, we are going to go ahead and represent our systems of equations using matrices, and then we are going to be using our graphing calculators to help us to solve those systems. I am also going to show you how to do that algebraically, so you'll need to know both methods, but you'll be able to use your calculators to help you verify and check your answers. So first of all, to represent systems of equations using matrices, we have to make sure that each equation is written in standard form. And hopefully you can recall that standard form was ax plus by is equal to c. And remember, a, b, and c all have to be integers, no fractions or decimals. So that was the first thing. So once you have all of the equations in standard form, the next thing we want to do, we have three different matrices we need to write. The first one is called the coefficient matrix. And the coefficient matrix basically is just all of the numbers in front of the variables. The second matrix we're going to write is the variable matrix. And the variable matrix is made up of just a matrix containing whatever variables are in our equations, whether it's x and y or a and b or whatever that is. And lastly, the third matrix is the right-hand side, or what we call the constant matrix. And this only has numbers in it. And what we're going to do is we are going to eliminate the variable matrix when we're writing our matrix for our graphing calculators. And we will be using what's called an augmented matrix that we input into our graphing calculator. This augmented matrix allows us to do some equivalent row operations when we're using algebra, and we're going to be using what's called the elimination method. That should be familiar to you, and we'll talk about that in some examples in the next couple of slides. So in this example, I just want you to be able to write a system of equations using matrices. So first of all, remember we have three matrices that we're going to write. The first one is called the coefficient matrix. So those are just the numbers in front of all of the letters or in front of the variables. So we have ones in front of our two x's and a 5, -3. We're missing the y term here, so we need a 0 and a 1 here, a 1, 3, and a 0 here. So that's where these numbers came from in this matrix. The second matrix is the variable matrix, and our variables are x, y, and z. And the third matrix is the right-hand side, or our constant matrix, made up of 6, 12, and 1. Now recall, if we do matrix multiplication, if we take row 1 and multiply that by this column, that will give us this equation right here. Okay, if we take 1 times x minus 3 times y plus 1 times z, and then that's equal to 6, that is actually our first equation there. So just a little review for you on matrix multiplication. So once we have our matrix written, we want to write this as an augmented matrix so that we can put this into our calculators, or so we can do our reduced row operations. And so what we're going to do is replace that variable matrix with this vertical line and then make it a single matrix where we add in that right-hand side, or that constant matrix. So that is the representation of the system of equations using an augmented matrix. Now, when we're solving these algebraically using matrices, our goal is to get ones along the main diagonal here. You'll see these ones. This is called the main diagonal. And the main diagonal occurs before this vertical line in our augmented matrix. So we want all ones, and we don't care what we get over here on the right-hand side. Once we have all ones in this main diagonal, we also want to get zeros above and below that main diagonal. Now this is called a reduced row echelon form matrix. So when we have our ones and our zeros, that is a reduced row echelon form. And once we have it in reduced row echelon form, that gives us our solutions. So in this example, our solution on the left-hand side, this would say whatever our variable, say it was x equals a then, and the answer for this one would be y equals b. This one we would have x equals a, y equals b, and z equals c. That'll make more sense when we do some examples in just a minute. So there are three main row operations that we're going to be doing using algebra. And these three operations are what your calculator uses to also solve matrices. One of the operations is switching any two rows. So we can switch any two rows. That should make sense to you. It doesn't matter what order our equations are in. We can switch which one is first, second, or third. And so in this example, I'm switching row 1 and row 2. So the new matrix becomes what I have shown here on the right-hand side. Okay, the third row stays the same, and we just switched row 1 and row 2. Another thing we can do is we can multiply any row by a constant. In this example, I've multiplied row 1 by 2. So row 2 and 3 stay exactly the same, but I've doubled row 1. We can add any two rows together. In this example, I'm adding row 2 to row 3, so the only thing changing is row 3. And row 3 becomes 7, 1, and 1. And then lastly, we can combine any of those operations. So in this example, I'm multiplying row 1 by -2, and then I'm adding that to row 2. So row 2 is the one that's changing. Row 1 and 3 stay exactly the same. Multiply row 1 by -2, so this I would have -2 plus 2 gives me 0. The second element, -2 times -3, is +6, plus 0 is 6. -2 times 1 is -2, and -2 plus 1 is -1. So that's where those numbers come from. In this example, we're going to go ahead and solve this system using matrices, and this one we're going to do algebraically. So first of all, we need to write our equations in standard form, and you can see they are already in standard form, so that step is done for us. The second step is to write the system of equations as an augmented matrix. So write your coefficient matrix, your vertical line, and your right-hand side. So there's the answer for that. Step 3 is to use row operations to put this in reduced row echelon form. That's where we want the ones along the main diagonal and zeros above and below. So we already have a 1 here. We need to get a 0 below. So we'll start with this. To get a 0 here, I could multiply row 1 by -2 and add it to row 2. And that's exactly what I'm going to do. When I multiply row 1 by -2, I get 0. -2 times 3 is -6, and a -1 gives me a -7. -2 times 22 is -44, plus 2 is -42. So that's where these numbers come from. Now I want to get a +1 right here, so I can divide by -7 for just this row 2. So when I do that, remember dividing by -7 is the same as multiplying by -1/7. I get a 1 and a 6. One more step, I need to get a 0 here, so I'm going to multiply row 2 by -3 and add it to row 1. So here's the symbols for that. -3 times row 2, add it to row 1. And when you're doing this algebraically, I'd like you to write this step out so I know exactly what you're doing, so I can check your math. So again, we've got a 1 here and a 6 here. If I multiply row 2 by -3, I get a 0 plus 1 is 1. -3 times 1 is -3. Add it to the 3 above and we get a 0. -3 times 6 is -18 plus 22 gives us a +4. So this tells me my solution. This one says x is equal to 4, y is equal to 6. And that's how we interpret our results with the augmented matrix. Here's another example for you. This one's a 3 by 3 to begin with, or a 3 by 4 for your augmented matrix. It's already in standard form, so we're going to go ahead and jump to the augmented matrix. This is a good time for you to maybe pause the video and see if you get this right. Here is your augmented matrix. Okay. So now this one, I am going to show you how to do this one on your graphing calculator. Okay, so the first thing we're going to do is use row operations to solve, and your calculator will do all of this automatically for you. So the first thing you want to do is to enter this thing into your calculator. So here I have the graphing calculator for you. So you want to use, see how it says matrix in blue? That's a second function, so we're going to go second, matrix, and we're just going to enter this in matrix A. So you got to scroll over to where it says edit, so move over 2 to the right into the edit and then hit enter. We're going to edit matrix A. So the matrix we're putting in is right here. This is a 3 row by 4 column. So it's 3 by 4. And once you enter that, then it's going to ask you for each element in order. So right now you can see what's highlighted is row 1, column 1, and that element is 1, so you can enter a 1. And then we want row 1, column 2 is a 4, row 1, column 3 is 6, row 1, column 4 is 21, and then just continue on. Then we want a 2. Now be careful here, -2, remember you got to use this for the negative, not the minus sign, or it'll give you an error. So we want -2 there, a 1, and a 4. Then lastly, in our last row, we want 0, -8, 1, and -1. So now we have our matrix all set to go, so we can just quit out of that. The next thing we want to do is to choose our ref. This is reduce row echelon form. So let me bring my calculator back up here. Hopefully I can get that. Where to go? Here we go. Just bear with me for a second. There we go. All right, so what I want to do now, I'm going to go back to my matrix, second matrix, and this time we want to go to the Math tab. Okay, and I want to choose, it's actually option B. If you scroll down until you start getting your letters 890AB. So we want the RREF, reduce row echelon, so then you just hit enter. And now we need to tell it what matrix we want. So again, go back to second matrix, and we are going to choose matrix A. So it's already highlighted, so just hit enter, and then hit enter again. You can see that it chose matrix A. And now we just need to interpret our results. So what this says, okay, we chose the matrix that we edited and we picked enter. Here are our results. This tells us the solution is x is 1, y is a half, z is 3. So that's how you interpret your solutions there, and here's the way it looks on your calculator. All right, so here is your lesson check for you. I've given you 2 examples. Go ahead and solve these. Let's do the first one algebraically and maybe do the second one on your calculator and bring those answers to class. See you next time.